In this video, we will be discussing the process ITRC recommends for the application of screening distances for petroleum vapor intrusion. The process involves three general steps. 1, developing the conceptual site model or CSM for screening. 2, assessing whether screening distances can be applied. And 3, if so, conducting the screening to determine whether the sites screen out or whether further data collection is necessary. Although the screening distance concept is relatively straightforward, there are some unique aspects that, if misunderstood, could lead to improper site screening. We will attempt to highlight these issues and other intricacies of site screening throughout the video. If you are unfamiliar with what screening distances are, we ask that you view the complimentary video on site screening titled "The Case for Change Petroleum Vapor Intrusion Screening." The first step is to develop a conceptual site model or CSM, which is a critical step in the proper application of site screening. The CSM can be developed from either site data that's collected during an initial site investigation, when chemical concentrations in soil and groundwater are typically assessed and contaminant sources delineated, or from pre-existing site data. It's important to note that soil gas and indoor air data are not necessary at this stage of CSM development or site screening. The first element of developing the CSM is to define your site type. Is the site a petroleum UST site or a petroleum industrial site, such as a refinery, terminal, or pipeline site? It's important to make this distinction because the screening distances recommended by ITRC for LNAPL sources are 15 feet if it's located at a petroleum UST site, or 18 feet if it's located at a petroleum industrial site. The reason for the difference is likely attributable to greater limitations on oxygen availability for aerobic biodegradation at petroleum industrial sites, which are more likely to have laterally extensive, large volume LNAPL sources compared to those found at petroleum UST sites. Of note, there's more confidence in the 15-foot distance defined for petroleum UST sites because the value is based on empirical data collected at hundreds of petroleum UST sites versus the 18-foot screening distance, which was based on data collected at only 9 petroleum industrial sites. It's also important to note that it may be possible to apply the 15-foot screening distance at a petroleum industrial site if the release volume is relatively similar with that which one might encounter at a petroleum UST site. Further details on how the vertical screening distances were derived can be found in a separate video on petroleum vapor intrusion titled "The Case for Change, Petroleum Vapor Intrusion PVI Screening." Identifying the source type, in particular whether it's LNAPL or dissolved phase, is a critical element of site screening. It's easy to misidentify the source in cases where residual LNAPL is present, which may look like a dissolved phase source if based solely on the lack of LNAPL appearing in a monitoring well. In such cases, one could wrongly apply the dissolved phase screening distance of 5 feet to an LNAPL source. To help minimize this, ITRC's 2014 PVI guidance contains information on general LNAPL indicators. These indicators are also discussed in more detail in a separate ITRC video titled "Bottoms Up to PVI Investigation." This video also includes additional information on site characterization that are important in developing a CSM at petroleum vapor intrusion sites. Knowing the location of a petroleum vapor source is important in identifying which buildings can be screened in and which can be screened out. In general, the vertical extent of a petroleum vapor source in soil or groundwater can be estimated to within a foot or two. As noted previously, ITRC recommends identifying where LNAPL is present based on invoking multiple lines of evidence and the LNAPL indicator criteria. PID readings greater than 500 ppm are one such criterion. If PID readings are reported in boring logs, then one could assume the top of an LNAPL source is either A, the base of clean soil where PID concentrations are below 500 ppm, B, the first encountered LNAPL where PID readings exceed 500 ppm, or C, the top of a maximum reported water table elevation. Estimating the top of the maximum anticipated water table elevation may require some professional judgment, such as adding a few feet to account for uncertainty if limited site data are available or the water table was recorded during a dry period with little precipitation. The LNAPL indicator criteria are also used for defining the lateral extent of an LNAPL source in soil or groundwater. The lateral extent of a dissolved phase source is defined based on agency-specific guidelines, such as maximum contaminant levels, detection limits, or risk-based screening levels. The lateral extent of a petroleum vapor source is generally less well known than the vertical extent, given that sites are characterized with monitoring wells and soil borings that are typically spaced on the order of tens of feet. The inability to accurately delineate the lateral edge of a petroleum vapor source in soil or groundwater is why lateral inclusion zones of 30 feet are recommended by ITRC for PVI screening. The lateral inclusion zone is a buffer distance used to account for uncertainty with knowing the exact edge of an LNAPL source or dissolved phase source in soil or groundwater. It is used to determine 1, if a building is close enough to the lateral edge of a vapor source to be considered for PVI screening, and 2, whether to apply a LNAPL or dissolved phase screening distance. The lateral inclusion zone is defined from the edge of the petroleum vapor source to the edge of a building foundation. Buildings located inside the lateral inclusion zone are screened in. Buildings located outside the inclusion zone are screened out. For LNAPL sources, the lateral inclusion zone extends 30 feet beyond where the vapor source is present in soil or groundwater. Any buildings located within this radius would require screening using the LNAPL screening distance. For dissolved phase sources, the lateral inclusion zone extends 30 feet beyond edge of the groundwater plume as defined by the governing regulatory agency. It may be possible to eliminate the need for the lateral inclusion zone provided the lateral edge of the vapor source can be defined with sufficient certainty. The last bit of information needed to inform the CSM is on the presence of precluding factors that could prevent one from being able to apply the screening distances. Types of precluding factors include A, preferential pathways, which may be natural, such as karst or fractured bedrock, or man-made, such as sewers and gravel backfill. B, expanding or advancing plumes. C, certain fuel types that were not assessed in the development of the screening distances, such as leaded gasoline or ethanol containing more than 10% ethanol by volume. And lastly, D, sites where certain soil types are present, such as peat or desert sand, where biodegradation may be limited. Recent studies have shown, however, that the vertical screening distances recommended by ITRC are still broadly applicable to sites with historic leaded gasoline releases. Now, armed with a good CSM, one can proceed to step 2 of the site screening process and assess whether the screening distances can actually be applied. This is done by first answering whether precluding factors are present. If yes, then a more thorough site investigation is recommended, such as the collection of soil gas or indoor air data. And if not, then one would apply the screening distance for that building located within the lateral inclusion zone. The application of the screening distances then constitutes step 3. And that brings us to the final step in the screening process, screening using vertical separation distances. If the screening distances can be applied, then one screens a building in or out based on whether the vertical source building separation distance is less or longer than the applicable vertical screening distances. One screens out if the vertical source building separation distance, or vertical separation distance for short, is greater than the applicable vertical screening distance. Conversely, one screens in if the vertical separation distance is less than the vertical screening distance. And that concludes this video. If you're interested in obtaining additional information on PVI, LNAPL, or TPH, please visit the following ITRC websites, which contain links to both guidance documents and fact sheets.
The Interstate Technology and Regulatory Council is a nonprofit research program of the Environmental Council of the States. ITRC is a state-led organization composed of over 1,000 members from state agencies, federal government, tribal and international organizations, the private sector, academia, and community stakeholders. Members participate in technical teams which produce guidance, tools, resources, and training materials. If you'd like to be a part of ITRC, please visit the ITRC website at itrcweb.org. You can register for teams and learn more about how you can be an active member. ITRC's usage policy is available on the ITRC website. If you do plan to use ITRC materials, we ask you to review that policy in detail and be sure to credit ITRC. ITRC does not warranty the material nor endorse any specific products.